When you hear the word volcano, what image appears in your mind? Perhaps it is a majestic, conical mountain, standing tall on the horizon, with a crater at its peak, like Mount Fuji in Japan or Vesuvius in Italy. They are symbols of natural power, both beautiful and fearsome. We can see them, measure them, and keep a safe distance from them. But what if I told you that the most dangerous volcanoes on the planet are the ones that we cannot see at all? Volcanoes with no peak, no steep slopes. Volcanoes so large that, in many cases, we are living, working, and traveling right inside their craters without even knowing it. This is the world of supervolcanoes, the sleeping giants of geology. They are not mountains, but giant caldera, scars left on the Earth's surface after eruptions in the past on a scale that the human mind can barely imagine. They hide in plain sight, disguised as peaceful valleys, clear blue lakes, or vast national parks. Welcome back to Science for Sleep. If this journey to explore the deep mysteries of our planet sparks your curiosity, a gentle tap of the like and subscribe buttons helps our community of contemplative souls grow stronger. And as always, I love to know where in the world you are listening from. Please feel free to leave a quiet greeting in the comments below. Tonight, we will together lift the veil of mystery, looking beneath the peaceful surface of the Earth to learn about these sleeping giants. This is a story of unimaginable power, of great geological cycles, and of the peace we find while living on a dynamic and vibrant planet. Let us begin. Our journey into the world of these invisible giants begins in a place of stunning and paradoxical beauty, Yellowstone National Park in North America. On the surface, it is a landscape of serene forests, vast grasslands, and abundant wildlife. It is famous for its geothermal wonders, a collection of over 10,000 geysers, hot springs, and bubbling mud pots. We see the famous Old Faithful geyser erupting on a predictable schedule, a magnificent plume of steam and hot water shooting into the sky. We see the Grand Prismatic Spring, a pool of water so large and brilliantly colored it looks like a fallen piece of the rainbow. These features are beautiful, and they draw millions of visitors who come to witness the power and artistry of nature. But this beauty is deceptive. It is merely the surface expression, the gentle breathing of an immense and terrifying power lurking just a few kilometers beneath our feet. For the entire park, in its vastness, sits within the giant, collapsed crater, the Caldera, of one of the world's largest and most active supervolcanoes. The geysers and hot springs are not just random geological quirks. They are the vents of a colossal subterranean engine. They are heated by a massive underground chamber of magma, a reservoir of molten and semi-molten rock so large that it could fill the Grand Canyon more than 11 times over. This magma chamber, the hot heart of the continent, is the remnant of a hotspot, a stationary plume of superheated rock rising from deep within the Earth's mantle, the same kind of plume that created the Hawaiian Islands. Over the last 2 million years, the Yellowstone hotspot has erupted 3 times in cataclysmic, caldera-forming The most recent of these, which occurred around 640,000 years ago, was 1,000 times more powerful than the 1980 eruption of Mount St. Helens. It blasted over 1,000 cubic kilometers of rock and ash into the atmosphere, covering half of North America in a thick, gray blanket. The ground then collapsed into the now empty magma chamber, creating the vast caldera that defines the park today. So when you walk through Yellowstone, you are not walking on solid ground. You are walking on the thin, fragile roof of a slumbering giant, a giant whose slow, deep breaths create the beautiful, steaming wonders on the surface. If Yellowstone represents the raw, untamed power of a supervolcano hidden beneath a pristine wilderness, our next destination shows us something perhaps even more unsettling, a supervolcano that lies dormant not under a remote park, but under the bustling cities and quiet coastal towns of a modern, densely populated country. We journey now to Italy, to the coastline near the city of Naples, to a place known as the Campi Flegrei, or the Phlegrean Fields. The name itself, which translates from the ancient Greek as the burning fields, is a testament to its long and fiery history. At first glance, you might not see a volcano at all. You see towns, harbors, ancient Roman ruins, and a beautiful bay. But this entire landscape, both on land and beneath the sea, is part of a vast, sprawling caldera, the collapsed crater of a supervolcano that has had two catastrophic super-eruptions in its past. One around 39,000 years ago, which was one of the largest in European history. Unlike the sparse population around Yellowstone, over 1.5 million people live directly inside this ancient and still very active crater. This supervolcano is famous for a unique and dramatic phenomenon, known as bradyseism, a word that means slow movement. The ground itself breathes. Over cycles of years or decades, the land can rise dramatically, sometimes by several meters, as the magma chamber below slowly fills and pressurizes the hydrothermal system above it. Then, just as slowly, it can fall again as the pressure subsides. The evidence of this is written into the very architecture of history. In the town of Posawelli, at the heart of the caldera, stand the marble columns of an ancient Roman marketplace. High up on these columns, far above the current sea level, are the boreholes left by marine mollusks, a clear and undeniable record that in the centuries after the Roman Empire fell, the ground here sank, submerging the market beneath the sea, before rising again. In recent times, this process has accelerated. In the 1970s and again in the early 1980s, the ground rose by more than 3 meters, causing thousands of small earthquakes and forcing the temporary evacuation of the town. Since 2005, a new period of uplift has begun, and the ground continues to rise slowly, accompanied by constant seismic tremors. Scientists monitor Campi Flegrei with an intense network of instruments, and while they do not believe a full-scale super-eruption is imminent, the immediate threat is the potential for a smaller, but still highly dangerous eruption within the caldera. Its last eruption was a relatively small one in 1538, which, over the course of just 1 week, created an entirely new mountain called Monte Nuovo. Campi Flegrei is therefore a different kind of giant. It is not a distant, wild power, but a restless neighbor, a part of human history whose slow, deep breaths constantly reshape the land and remind the millions who live above it of the immense geological forces that are always at work, just beneath their feet. The threats posed by Yellowstone and Campi Flegrei are, for now, largely theoretical, a story of future potential. But to understand the true global consequences of a super-eruption, we must journey back in time to an event that directly impacted our own human ancestors and may have pushed our species to the very brink of extinction. Our destination is the island of Sumatra in Indonesia, around 74,000 years ago. At this time, early modern humans, Homo sapiens, had already begun their great migrations out of Africa and were establishing small populations across Asia. They were skilled hunter-gatherers, adapting to new environments, but they were about to face a planetary challenge of unimaginable scale. This was the eruption of the Toba Supervolcano. It was one of the largest explosive eruptions in the last 25 million years, a cataclysm so immense it is difficult to comprehend. The eruption blasted nearly 3,000 cubic kilometers of rock, magma, and ash into the sky, enough material to cover the entire Indian subcontinent in a thick, grey blanket. The colossal plume of ash and sulfur dioxide rose high into the stratosphere, where it was caught by global atmospheric currents and spread across the planet. This created a thick, persistent veil that shrouded the world, blocking a significant portion of sunlight from reaching the Earth's surface. The consequences were dramatic and swift. Global average temperatures are estimated to have plummeted by as much as 5 to 15 degrees Celsius, triggering a decade-long volcanic winter. This was a world of perpetual twilight, of cold and failing rains. In the northern hemisphere, summers were erased. In the tropics, monsoons failed. Ecosystems across the globe, unable to adapt to the sudden darkness and cold, collapsed. The plants withered, and the animals that fed on them starved. This sudden and prolonged winter led to what is now known as the Toba catastrophe theory. This hypothesis suggests that the eruption caused a dramatic reduction in the global human population, a genetic bottleneck that brought our species perilously close to extinction. Genetic evidence from modern humans does show that our species went through a period around this time where our effective population was incredibly small, perhaps reduced to only a few thousand individuals worldwide. Imagine small bands of our ancestors struggling to survive in a world where the plants were dying. The animals they hunted were disappearing, and a cold, grey ash constantly fell from the sky like snow. While the exact severity of this human bottleneck is still debated among scientists, there is no doubt that the Toba eruption was a global event of immense proportions that profoundly impacted the planet's climate and every living thing on it. The story of Toba is a humbling reminder written in our own DNA. It is a warning from our deep past of the planet's power to reshape the world in an instant. And it is a testament to the incredible resilience of the few thousand ancestors who managed to survive the long winter, allowing us to be here today. The story of Toba tells us of the immense destructive power of a super-eruption, an event that can change the climate of the entire planet. But it also helps us answer a fundamental question. If these volcanoes are so massive, why can we not see them? Why are there no colossal mountains marking the sites of Yellowstone, Toba, or Campi Flegrei? The answer is that a supervolcano's eruption is an event so vast that it does not build a mountain. It consumes it, leaving behind a completely different and much more subtle geological feature, a caldera, a normal crater, the kind we see at the top of a typical conical volcano, is formed by the outward explosion of material from a central vent. A caldera, which comes from the Spanish word for cauldron, is formed by the inward collapse of the ground itself. Imagine a vast underground chamber, many kilometers beneath the surface, filled with an enormous volume of molten and semi-molten rock. This magma chamber is the heart of the supervolcano. During a super-eruption, this chamber is almost completely emptied in a very short period of time. Geologically speaking, as thousands of cubic kilometers of magma, rock, and ash are violently ejected onto the surface. The eruption is like pulling the plug on this immense subterranean reservoir. The land above, which is the roof of this vast, now empty chamber, is left without support. This roof, which can be kilometers thick and stretched for dozens of kilometers across, now hangs precariously over a great void. Under its own colossal weight, it begins to fracture. Great, ring-shaped faults and cracks appear on the surface, tracing the outline of the empty chamber below. Then, in a slow, catastrophic subsidence that can take hours or even days, the entire block of land collapses downwards, sinking into the void left by the evacuated magma. This is not a small sinkhole. This is a section of the Earth's crust, sometimes 50 or 60 kilometers wide, dropping by hundreds or even thousands of meters. What is left behind is not a peak, but a huge basin or depression in the ground. This is the Caldera. This is the supervolcano. This is why they can hide in plain sight. The Yellowstone caldera is so large that it encompasses a significant portion of the national park, its boundaries only truly visible from space. The Toba caldera is so vast that it is now filled with the largest volcanic lake on Earth. Lake Toba, and the Campi Flegrei, is a caldera that contains entire towns, historical ruins, and a portion of the Bay of Naples. Over hundreds of thousands of years, these immense depressions can be filled in by sediment, further disguising them until only the trained eye of a geologist can recognize the true nature of the landscape. But the story does not always end with the collapse. Deep below, the geological hotspot that fed the volcano is still active, and the magma chamber can slowly begin to refill. As new magma pushes up from the mantle, it can cause the floor of the caldera to swell upwards, creating what is known as a resurgent dome. This very process is happening today at both Yellowstone and Campi Flegrei, a subtle, yearly rise and fall of the ground that tells us the sleeping giant is not dead, but is merely breathing in its long, deep slumber. A supervolcano, then, is not a mountain we look up at, but a landscape we stand within. It is a testament to a power so great that it consumes the very mountain it might have built. It is a quiet, colossal scar on the surface of our world, a silent reminder of the immense void and the fiery heart that lies just beneath. We now understand that a supervolcano is a vast, sunken caldera, a scar left by a mountain that consumed itself. But what is the anatomy of the eruption itself? What is the slow, inexorable sequence of events that leads to such a catastrophic collapse? It is a story of immense patience and unimaginable pressure unfolding in geological slow motion deep beneath the surface. It begins with the magma chamber. This is not a cavern of liquid fire as one might imagine, but a massive, sponge-like body of molten, semi-molten, and solid rock, a mushy, crystalline heart that can be dozens of kilometers wide. Here, over hundreds of thousands, or even millions, of years, magma from the Earth's mantle slowly accumulates. The magma that feeds supervolcanoes is often highly silicic, meaning it is rich in silica. This makes it extremely viscous, thick, and sticky, more like cold honey or thick tar than the fluid, runny lava that creates the gentle shield volcanoes of Hawaii. This thick, sticky nature is the key to its destructive potential. Unlike fluid magma, which allows volcanic gases like water vapor, carbon dioxide, and sulfur dioxide to bubble up and escape gently, this viscous magma traps these gases within itself. The gases remain dissolved in the molten rock, held in place by the immense pressure of the overlying crust, like the fizz in a sealed bottle of soda. Year after year, century after century, more magma and more gas are added to the chamber from the mantle plume below. The chamber swells, and the pressure builds relentlessly. This immense pressure pushes the ground above it upwards, creating a vast, subtle dome that can rise by meters over millennia. And then, after an age of slow, silent build-up, something provides the final push. The trigger for a super-eruption can come in several forms. Often, it is a new injection of hot, buoyant, basaltic magma from deeper within the mantle. This new magma forces its way into the bottom of the existing silica-rich chamber. This sudden addition of heat and material acts like violently shaking the soda bottle. It causes the trapped gases to rapidly come out of solution, flash into vapor, and catastrophically increase the pressure beyond what the roof of the chamber can contain. Another possible trigger is a major earthquake on a nearby fault line. A powerful seismic event could create large fractures in the rock that forms the roof of the magma chamber. These fractures would instantly release the pent-up pressure, again, causing the dissolved gases to explosively decompress. Whatever the precise trigger, the result is the same. The integrity of the magma chamber's roof is breached. The sleeping giant, after an age of quiet, violent slumber, finally awakens, and the anatomy of the eruption transitions from a story of contained pressure to one of unimaginable release. The moment the roof of the magma chamber fails, the eruption begins, and it is an event of two distinct, equally terrifying acts. The first is the initial, vertical blast. With the immense pressure suddenly released, the dissolved gases within, the magma instantly and violently expand, creating an explosion of almost incomprehensible power, an explosion equivalent to thousands of atomic bombs detonating at once. A colossal column of ash, rock, and superheated gas is punched upwards into the atmosphere with tremendous force, reaching heights of 30, 40, or even 50 kilometers high into the stratosphere, far above the weather and the clouds. But this is only part of the story. As this great plume rises, the newly created caldera, the giant collapsing crater, is itself a source of immense destruction. From the ring fractures and fissures that form along the edges of the collapsing caldera, the second act begins. This is the pyroclastic flow. It is not lava. It is something far faster and more deadly. It is a dense, ground-hugging avalanche of superheated gas, ash, and volcanic glass, a turbulent cloud heated to hundreds of degrees Celsius, moving at supersonic speeds. It does not flow like a river. It billows and surges across the landscape, a grey, roaring tidal wave of destruction that incinerates and smothers everything in its path. Forests are vaporized in an instant. Valleys are filled. Hills are erased. The flow is so hot and so fast that it moves on a cushion of its own expanding gas, allowing it to travel for hundreds of kilometers from the source, ignoring the topography of the land, climbing over hills and spreading across vast plains. Anything caught in its path, any plant, any animal, any trace of life, is turned to ash in a fraction of a second. This is the immediate, local apocalypse. The fiery storm that completely sterilizes a region the size of a small country, leaving behind a new, thick layer of hot, grey, lifeless rock. And as this initial wave of fire and ash scours the land clean, the great plume in the sky continues to rise, preparing for the next, more patient and global phase of the catastrophe. While the firestorms of the pyroclastic flows remake the world on a local scale, the great column of ash and gas continues its journey upward, a dark pillar connecting the fiery heart of the earth to the cold emptiness of space. It punches through. The the troposphere, the layer of weather and clouds. In a matter of minutes, rising higher and higher until it reaches the stratosphere. This is a high, stable layer of the atmosphere, far above the rain that could wash the debris out. And here, the ash cloud begins to spread. Like a monstrous, grey anvil, the top of the plume flattens and expands, fanning out across the upper atmosphere. The great jet streams, the high-altitude rivers of air that circle the planet, catch this vast cloud of fine volcanic ash and sulfur dioxide. They begin to pull it apart, stretching it into long, thin veils that start to wrap around the entire globe. Day by day, week by week, the sky begins to change for everyone on Earth, even those living on the opposite side of the planet from the eruption. At first, the sun might appear hazy, then a pale, sickly disk in the sky, its warmth diminished. Eventually, for much of the world, it would be blocked out almost completely. The planet would be plunged not into total blackness, but into a deep, perpetual twilight, a world without a proper day, lit only by a dim, grey ambient light. And then the ash begins to fall. A fine, grey, talc-like powder would rain down silently from the sky, covering everything in a soft, uniform blanket. It would cover the leaves of the few surviving plants, choke the rivers and streams, and blanket the land in a layer of sterile dust. The world would become quiet. The falling ash would muffle all sound, creating a deep, profound silence, broken only by the whisper of the wind. The rising darkness is now complete. The planet is shrouded, cut off from the life-giving light and warmth of its star. The fire from the Earth's heart has been answered by a deep and lasting darkness in its sky. And under this veiled, twilight sky, the long, cold season of the volcanic winter is about to begin. With the planet now shrouded beneath a persistent veil of stratospheric ash and sulfur aerosols, the most fundamental engine of life on Earth begins to fail. The light of the sun, the fine ash particles, and more importantly, the sulfate aerosols, formed from the sulfur dioxide gas, are highly reflective. They act as a vast planetary mirror, reflecting a significant portion of incoming sunlight back into space before it can reach and warm the surface. This triggers the most devastating, long-term consequence of a super-eruption, a volcanic winter. Global average temperatures could plummet by 5, 10, or even more degrees Celsius. A sudden and dramatic shift that ushers in a new, artificial ice age that could last for a decade or longer. On land, the first victims of this cold, dim world are the plants. In the perpetual twilight, photosynthesis, the process that powers nearly all terrestrial life, grinds to a halt. Unable to convert sunlight into energy, the great forests, the ferns, and the grasses begin to wither and die on a global scale. The landscape is transformed into a world of grey and brown. Next, the herbivores, the great plant eaters who depended on this abundant vegetation, begin to starve. Their food sources are not only dying from the cold and lack of light, but are also covered in a blanket of fine, abrasive, and often toxic volcanic ash. Then, as the herbivore populations collapse, the carnivores, the predators at the top of the food chain, find their own prey disappearing, leading to their own eventual starvation. A great, silent famine sweeps across the continents. In the oceans, a similar catastrophe unfolds. The lack of sunlight kills off the phytoplankton, the microscopic marine plants that float in the upper layers of the water and form the base of the entire oceanic food web. As the phytoplankton die, so do the tiny creatures that feed on them, and this wave of death cascades up the food chain, from small fish to the largest marine predators. The world becomes quiet. The falling ash muffles sound, creating a deep, profound silence, broken only by the mournful whistle of the wind over a frozen, ash-covered landscape. This is the true, global reach of a super-eruption. It is not just a local explosion. It is a planetary event that can switch off the sun and dismantle entire ecosystems from the bottom up. It is a reminder that all life on Earth, from the smallest microbe to the largest creature, is connected by its shared dependence on a steady stream of light from a star 150 million kilometers away. The fire from within the Earth has created a deep and lasting winter on its surface, leaving a silent, frozen, and starving world. But even in this profound devastation, life, in its most resilient forms, endures, waiting for the sky to clear. The world after a super-eruption is a world of profound silence and stillness. A planet in a deep and frozen slumber under a veiled, grey sky. But even in this seemingly endless winter, deep within the planet's most sheltered corners, life endures. The devastation, while global, is not absolute. Pockets of life survive in what scientists call refuge. Deep in the ocean, near the geothermal heat of hydrothermal vents, entire ecosystems powered by chemical energy, not sunlight, may continue on, oblivious to the darkness on the surface. On land, perhaps near volcanic hot springs, the ground remains, warm enough for microbes and even some hardy plants to survive, and seeds, the ultimate time capsules of life, can lie dormant for years or even decades under a protective blanket of ash, waiting patiently for the sun to return. For years, the sky remains a dim veil, but slowly, inevitably, the finest ash particles and sulfate aerosols begin to fall out of the stratosphere. The first weak rays of sunlight begin to touch the Earth's surface again. And with the return of light, the great recovery begins. The first to recolonize the vast, sterile landscape are the pioneer organisms. In the oceans, it is the microbes. On land, it is often the ferns. Ferns are masters of colonizing disturbed land. Their spores are incredibly light and can travel for thousands of kilometers on the wind, seeking out any patch of ground where they can take hold. In the rock layers that mark the aftermath of great extinctions, scientists often find a fern spike, a sudden, overwhelming abundance of fern. Spores in the fossil record. Imagine it, a world of grey, uniform ash, and then the first sign of vibrant color. The bright, hopeful green of a single fern, uncurling its fronds in the weak, returning sunlight. These pioneer plants begin the slow, arduous process of creating new soil. Their roots break up the compacted ash, and as they live and die, their organic matter enriches the sterile ground, making it possible for other, less hardy plants to eventually take root. After the ferns come the shrubs, and then, over centuries and millennia, the first new forests begin to grow. And as the plants return, so do the animals. The few surviving species of insects, small mammals, and reptiles emerge from their burrows and shelters into a new, simplified world. The food web, once torn to shreds, begins to reweave itself, thread by patient thread. The recovery from a super-eruption is not a rapid process. It is a testament to the slow, patient, and unshakable power of life. It is a story told over thousands and millions of years. A story of the first green sprout pushing its way through a world of ash. Life had been pushed to the very brink, but it had not been extinguished. It held on, it adapted, and it began. The long, quiet work of reclaiming the planet, setting the stage for the next great chapter of evolution. The story of life's recovery after an eruption is a testament to the planet's incredible resilience. But the giants themselves do not sleep forever. And in our modern world, with our sensitive instruments, we can, for the first time in history, listen to their quiet, slumbering breaths and feel their subtle, stirring movements. These are the current signs of unrest, the faint whispers that tell us these systems are still very much alive. At Yellowstone, the most obvious sign is the movement of the ground itself. The entire Caldera floor breathes on a decadal cycle. Satellite measurements and GPS stations on the ground have shown that, from 2004 to 2010, the ground swelled upwards at a rate of several centimeters per year. A clear sign that the vast magma chamber below was slowly expanding, perhaps from a new injection of molten rock. Then, from 2010 onwards, the process reversed, and the ground began to subside again. This is the slow, deep inhalation and exhalation of the sleeping giant. The second sign is the constant seismic chatter. Yellowstone is one of the most seismic active areas in the United States, experiencing between 1 and 3,000 earthquakes every year. Most are too small for humans to feel, but they are recorded by a dense network of seismic. They often occur in what are known as earthquake swarms. Not one large quake, but hundreds or even thousands of small tremors that can occur over days or weeks. This is the sound of the Earth's crust shifting and cracking under the immense pressure. As superheated water, gas, and magma move through the complex subterranean plumbing deep below. At Campi Flegrei in Italy, this breathing is even more dramatic and more personal. Here, the phenomenon of bradysism means the ground rises and falls in a way that is clearly visible over a human lifetime. After the major uplift in the 1980s, which forced evacuations, the ground subsided, only to begin rising again since 2005. This ongoing uplift is accompanied by persistent earthquake swarms and changes in the gases being released from vents on the surface. Unlike the wilderness of Yellowstone, here the ground is rising beneath homes, roads, and historical landmarks. The size of this giant are felt directly by the hundreds of thousands of people who live within its ancient crater. It is essential, however, to understand what these signs mean and what they do not mean. They mean that the supervolcanoes are alive. Their magma chambers are not cold, dead rock, but are active, dynamic systems. They do not, however, mean that a catastrophic eruption is imminent. This kind of activity, ground deformation and earthquake swarms, is considered normal behavior for a living caldera. It has likely happened many times over the past thousands of years without leading to a major eruption. These are the giant's sighs in its sleep, not the roar of it awakening. But these whispers are the very reason we must listen so carefully. And this leads us to a new part of our story. Not just observing the giant, but actively listening to it, using the full power of modern science to understand its every tremor and every stir. These restless sighs from the heart of the planet are no longer a complete mystery. While we cannot stop these geological giants, we can, for the first time in history, listen to them. We can monitor their every stir, every tremor, and every breath, using an incredible array of modern technology that acts as a planetary-scale stethoscope. The first line of observation is listening for the heartbeat of the Earth. A dense network of highly sensitive seismometers is scattered across the calderas of Yellowstone and Campi Flegrei, listening 24 hours a day, 7 days a week. They can detect the smallest tremors, the thousands of tiny earthquakes that signaled the movement of magma, hot water, and gas through the complex subterranean plumbing deep below. By analyzing the precise location, depth, and character of these quakes, scientists can create a three-dimensional real-time map of the activity within the volcano's restless heart. Next, we measure the planet's breath itself. High-precision Global Positioning System, or GPS. Stations are anchored permanently to the ground throughout these active regions. These instruments are far more sensitive than the GPS in your phone. They can detect changes in the ground's elevation as small as a single millimeter. They provide a continuous record of the caldera floor swelling and subsiding, telling scientists whether the great magma chamber below is slowly inflating with new molten rock or deflating as it cools and contracts. From space, radar satellites use a technique called INSAR to create vast, detailed maps of this ground deformation, revealing subtle, widespread patterns of uplift that might be missed from a single point on the ground. We also analyze the giants' breath directly. Scientists regularly sampled the gases escaping from the fumaroles, geysers, and steaming vents, like those at Yellowstone. They look for changes in the chemical composition, particularly a sudden increase in gases, like sulfur dioxide or helium that have been dissolved in fresh magma rising from the deep. All of this data flows constantly into dedicated volcano observatories, where teams of scientists analyze it around the clock, watching for any deviation from the volcano's normal, slumbering behavior. It is crucial to understand that a super-eruption cannot happen without clear and massive precursors. The geological forces involved are simply too immense to go unnoticed. Scientists expect that before such an event, there would be a dramatic escalation in all these signals. Earthquake activity would increase in frequency and intensity, becoming shallower as magma moves closer to the surface. The ground would swell at a much faster rate than ever recorded before, and the amount and composition of escaping gases would change significantly. These warning signs would likely unfold over a period of weeks, months, or more probably years or even decades, providing humanity with a clear warning and time to prepare. So, we are not living in ignorance. We are living in an age of incredible observation. We listen to the earth, not with fear, but with respect and curiosity. Science has given us a flashlight in the dark, allowing us to watch the sleeping giants and begin to understand their ancient rhythms. And this knowledge, this ability to listen, is our greatest source of peace and security. Our modern scientific understanding allows us to listen to the planet with a sense of calm preparedness. But for most of human history, these great mountains of fire were not seen as geological processes. They were gods, monsters, and the very gateways to the underworld. Ancient cultures across the world, living in the shadow of these active peaks, developed rich and powerful mythologies to explain their terrifying and unpredictable nature. To the ancient Greeks, Mount Etna was the forge of Hephaestus, the god of fire and metalworking. To the indigenous peoples of the Andes, the mountains were powerful spirits, or apis, that had to be respected and appeased with offerings. And in Hawaii, the goddess Pele, a deity of both destruction and creation, was believed to reside in the Halema-Uma-U crater of the Klauia volcano. Eruptions were seen as divine anger, cosmic battles, or sacred acts of creation and humanity's role was to watch, to worship, and to hope for mercy. And yet, despite the obvious danger, humanity has always been drawn to live on the very slopes of these volcanoes. This is the great paradox of our relationship with them. For the same geological forces that bring destruction also bring incredible fertility. Volcanic ash, over time, weathers into some of the most nutrient-rich soils on Earth. The fine particles are filled with minerals like potassium, phosphorus, and other trace elements essential for agriculture. These fertile lands have, for millennia, supported dense and thriving civilizations. The slopes of Vesuvius supported the rich farms and prosperous vineyards of the Roman Empire. The volcanic soils of Indonesia and the Andes have sustained large populations for centuries. The story of Pompeii stands as a permanent and tragic reminder of this duality. It was a thriving, sophisticated Roman city that flourished because of the volcano's gifts, only to be consumed and perfectly preserved by its power in 79 AD. Our relationship with these sleeping giants has always been one of a delicate, dangerous balance, a dance between creation and destruction. We have moved from worshipping them as gods to studying them with science, but the fundamental paradox remains. We are drawn to the very power that could one day erase us. This long, shared history reminds us that our human story is inextricably linked to the much deeper, slower story of the planet itself. This long, shared, and often dangerous history between humanity and volcanoes forces us to confront a humbling truth. A truth that helps us put the immense power of supervolcanoes into their proper and peaceful context. The concept of geological time. The signs we see today, the rising ground at Campi Flegrei, the earthquake swarms at Yellowstone, are real and significant. They tell us that these giants are not dead, but are merely in a deep and long slumber. And it is a geological certainty that a super-eruption will happen again at some point in the Earth's future. The processes that drive them, the great engine of plate tectonics and mantle plumes, are as fundamental to our planet as its rotation. But the word future in geology is a very different concept from the future in our human lives. Our lives are measured in days, years, and decades. The planet's life is measured in epochs and eons, in millions of years. The average time between super-eruptions at a place like Yellowstone is on the order of 600 to 800,000 years. The last one was about 640,000 years ago. This does not mean we are due for another one, as these cycles are not as predictable as a ticking clock. But it does mean that the probability of such an event happening within our lifetime, or even within the next several thousand years, is incredibly, vanishingly small. We are living in a moment of geological peace. The great forces that can trigger these events are always at work, but they operate on a timescale that is profoundly slow and patient. We are a mayfly, living for a single day on the bank of a great river that has been flowing for millennia and will continue to flow for millennia. More, the river will surely flood again one day, but the chance of it happening on our specific single day of existence is extremely low. And so, this knowledge should not bring fear. It should bring a sense of profound humility. It invites us to appreciate the incredible stability and peace of the geological moment we happen to find ourselves in. It allows us to see these sleeping giants not as imminent threats, but as a reminder of the immense, patient power that has shaped our world, and of our own small, fleeting, and precious place within it. And so, we are reminded of the two great time scales of our existence, the frantic, fleeting scale of a human life, measured in breaths and heartbeats, and the deep, slow, patient scale of the earth. measured in the shifting of continents and the cooling of its core. To know that we live on the roof of these sleeping giants, these continent-sized engines of creation and destruction, is not a cause for fear. It is an invitation to a profound sense of humility and awe. The immense power churning in the planet's interior is indifferent to our lives, our cities, and our histories. It follows its own ancient thermal rhythm, a pulse that has beaten for billions of years before we arrived and will continue to beat long after we are gone. And there is a strange and profound peace to be found in that recognition. It frees us from the illusion that we are in complete control. It reminds us that we are a small but beautiful part of a much, much larger story. We build our lives on a thin, fragile crust, and yet we build them with love, with hope, and with a quiet trust in the ground beneath our feet. The peace we seek is not found in a world without danger, for no such world has ever existed. The peace is found in our ability to feel wonder in the face of immense power, to find beauty in a system so much greater than ourselves, and to accept our place within these grand, natural cycles. The sleeping giants beneath Yellowstone and Campi Flegrei will continue to breathe in their geological slumber. Their size will be measured by our instruments, their secrets slowly revealed by our science. But tonight, they are quiet. And in this quiet moment, you too can find your own stillness. Let the deep, slow rhythm of the planet be a comfort. Let the knowledge of its immense patience reassure you. You are safe on the rim of a sleeping world. And there is nothing more to do tonight than to trust in its quiet and to find your own. Sleep well.